Now we're on the last problem on sample final part 2. This is problem number 19. Suppose the sum of three vectors u, v, and w are shown in the figure is the zero vector. That means when you add them up, you get the zero vector or they're in equilibrium. If the magnitude of w is 180, they want us to find the magnitude of u and the magnitude of v. So let's go ahead and capture this vector representation on my iPad and begin working on the problem. So I'll take a screenshot, and we know that the magnitude of w is 180. I'll send this to my iPad, and then we'll go ahead and begin working. I don't know if the picture's sent. So now I've captured the problem out onto my iPad. We know that the magnitude of w is 180, so I'll label that. We also notice that vector v is in the first quadrant, so I know that both the components x and y are positive, so I use this little notation with plus plus. For vector u, it's in the third quadrant, so both the x value and the y value are going to be negative, so I do minus minus. And then w, which is in the fourth quadrant, the x is positive there, but the y value is negative. I'm also going to use the fact that in order to find the x component of a vector, when you know the magnitude, x is given by the magnitude of w times the cosine of the angle, and that's if you have the direction angle, so I'm going to call it theta, and then y is equal to the magnitude of w sine theta, and that would be for finding the components of vector w. So to find x and y, you would just take the cosine of the direction angle times the magnitude, and for y, the magnitude of the vector times the sine of the direction angle. And so let's go ahead and find each of the components for u, v, and w. So for v, we have that the magnitude are going to both be positive, so it's going to be the magnitude of v times the cosine of 28, because we have the angle is 28 for our vector v, and then we're going to have the magnitude of v sine of 28. For vector u, we have the magnitude of u cosine 15, the magnitude of u sine of 15, but 15 degrees is the reference angle, it's not the direction angle. So what I need to do is make sure I take advantage of the fact that I know that it's in the third quadrant, therefore both the x and the y are negative. So let me go ahead and add in that negative for both of those. So I'll have minus here, and that's going to be the case for u because it's in quadrant 3. Let's do the same for vector w. So w is going to have a positive component for x because we have the first component is positive, so it's going to be the magnitude of w, but the magnitude of w is 180. So it's going to be 180 times the cosine of 71 degrees. But for the second component, we're going to have that it's negative, so I'm going to need to make sure I add in that negative component. So it's going to be the negative 180, sine of 71 degrees. In order for these vectors to equal the zero vector, which is 0, 0, that means each one of the components need to add to 0. In other words, the first component, or the x component of v, and the x component of u, and the x component of w need to add to 0. So let's capture that on our next page. So here we have the x component equal to 0. So notice we have cosine 28, cosine 15, cosine 71. And for the y component, we have sine 28, sine 15, sine of 71. Since our question is asking us to find the magnitude of u and the magnitude of v, I'm going to let x represent the magnitude of u. Let's let it represent the magnitude of v. So x is equal to the magnitude of v, and y is going to equal the magnitude of u. Notice that these x values are not the same as saying the x component. We're just using x and y because we want to use the graphing calculator on Alex, and that will be helpful for us. All right, so then when we substitute in, we have the following. We have x cosine of 28 degrees minus y cosine of 15 degrees equal to negative 180 cosine of 71 by adding the opposite of 180 cosine of 71 to both sides. For the second equation, we'll have x times the sine of 28 degrees minus y times the sine of 15 degrees equaling a positive 180 sine 71. In order to use the Alex calculator, we want to solve for y in terms of x. And so what I'll do is I'm going to add the 180 cosine of 71 and then add the y cosine of 15, so they'll have the y value be positive. So I'll have x cosine of 28 minus, actually plus 180 cosine of 71 equal to y cosine of 15 degrees. Now if I divide both sides by cosine of 15, I've gone ahead and solved for y. So let's do that. Divide both sides by cosine of 15, and on the right hand side it'll cancel. So now I have y in terms of x, so I can use the graphing calculator. Let's do the same thing for the second equation. So this time I'm going to subtract 180 sine 71 and add y sine 15. So I'll have x sine of 28 minus 180 sine of 71 degrees equal to y times the sine of 15 degrees. Dividing both sides by sine of 15, we get x sine 28 minus 180 sine 71 all over sine 15 degrees is equal to y. So now we have two equations with y in terms of x, and we can use the graphing calculator. So let's go ahead and add in the graphing calculator so we can see that. All right, so I'm going to pull up the graphing calculator. Oh, there we go. I'm going to select y equals. I'll put in the first equation, and the first equation was x cosine 28. So x, and I think if you type the letter c, it automatically puts in cosine 28 plus 180 cosine 71 all over cosine of 15. So I think if I double click, it highlights the sum divided by c space 15. So now I have the first equation. Now let's go to the second equation. So my second equation, it's going to look very much like the first one, except for instead of cosines, I'm going to have sines. So I'm going to copy it. I don't know if it'll let me do that. So I copied and paste, and then I'm just going to change that cosine to sine. And then this one's going to be negative, so make sure I make that a minus 180. Again, I'll put my cursor in front of the 71 and change that to S. That changes it to sign. Put my cursor in front of the 15, delete, and hit S, and that puts in the sign. So now I have my two equations, and I'm just making sure that they match up. Now that I have my two equations, I'm going to hit graph. And when I first graph, I don't see anything because those values are out of the bounds of -10 to 10 in the X and Y direction. So if I hit the zoom button and zoom out, and you don't want to zoom too quickly because it'll lock the calculator. And that means you have to re-enter those two equations. And I begin to see one part of a line there after 3 clicks. And 4 clicks, and there we go. So 5 clicks in, I'm able to find the point of intersection. Once I find that point of intersection, I can hit graph. But you know what? I think I know why. I didn't change the mode. I messed up. Let me hit cancel. And I need to go back, and let's go back here to zoom, and let's just reset the zoom. Let's hit cancel. I didn't pick the mode. The mode is in radians. That's why the values weren't showing up. It needs to be in degrees because these values are in degrees. So first change the mode to degree, then go to graph. And then since you don't see anything, then zoom out. 1 click, 2 clicks, 3 clicks, 4, 5, 6, 7 more clicks. So anyway, so there we have it, is our graph that we can see the point of intersection. And then if we select intersect, you can move over the graph once the hand turns yellow or one of the lines turns yellow. That means you can move that line of intersection and you can see, oh, it's right about there. But you really don't need to. If you leave it where it starts and selects find intersection, it will find the intersection for you. So you have X is 798. And we have 0.224, and they say to round to the nearest tenth. And then we have Y is equal to 790.322. And when we round to the nearest tenth, we get 798.2 and 790.3. And then you recall that we let X equal the magnitude of V, and Y was the magnitude of U. And then Y was the magnitude of U, which is 790.3. So let's go ahead and check our answers. So U was 790 point. So there they let, U is written first, so they probably let that be X. It turns out it doesn't matter. You're going to still get the same equation, 798. You're going to still get the same values. So 798.2 is going to represent the magnitude of V. So it might be easier to keep it straight. Yeah, let X be U. Keep it in alphabetical order. All right, and let's check our work. Woohoo, and we got it correct. So I hope this last video on problem number 19 on finding the magnitude of the vectors when they are in equilibrium, that means they sum to 90 if you know one of the magnitudes.